is basically what that's telling me is, oh, how do I want to put this? Let's put it this way. We're in the back of the 6-7 notes. We are going to switch the signs of our zeros. And we're going to make binomials out of them. Now, here's what I mean. What I'm going to do, basically they're giving me the answers, and they want me to create the problem. So, when they tell me that I have a 0 of 2, basically what that means is, I'm going to make a set of parentheses, and I see 3 of them, so I'm going to make 3 sets of parentheses. Each one's going to start with x, or if you want to use a different variable, you could. And if you think about when we're solving for something, normally we take the set of parentheses, we set it equal to 0, we find the answer. So here it says switch the sign of the 0. Okay, that's positive 2. I'd make it negative 2. That's positive 1. I'm going to make it negative 1. That's positive 4. I'm going to make it negative 4. Because here's what I want you thinking about. We're doing one of these problems in reverse. Because if you think about it, if I were to take x minus 2 and set it equal to 0, well, how would I solve for x? I'd add 2 to each side, and I'd end up with x equals 2, which is one of my zeros. Or if I did it with x minus 1 equals 0, I'd add 1 to each side. X equals 1. Okay, that's one of my answers. That's one of my zeros. So you're like, am I done? Not quite. They want us to turn this into the original polynomial. So I'm going to take these 2 sets of parentheses, or 2 quantities at a time, and I'm going to multiply them out. If you're a fan of FOIL, FOIL it. I've seen a lot more of you in the homework that I've looked at using the box on things like this. Now, again, if you want to FOIL, you can. Doesn't matter. But I just like the box because it organizes me and it makes sure that I get everything done correctly. So, as I'm doing this, remember, we multiply to fill the box. And once I've multiplied to fill the box, then I'm going to go ahead, I'm going to start with my largest degree, and I'm going to work my way through and combine like terms. Now again, that's not the final answer, because that only takes into consideration these first 2. So to get that last one ready to go, I'm going to have my 3 terms, and then I have this one last binomial here, this x minus 4. So I'll move that in along the side here, and then again, I'm multiplying to fill the box. And when we're dealing with exponent terms, that means we're going to add exponents. And the critical thing here is just taking your time and making sure that, like, you don't leave something that's like negative 3x instead of putting the squared on there, or something like that. So we work our way through. And again, the cool thing with the box is if there are like terms, they'll always be in the diagonals. So I'll start with my largest degree, go with my like terms, again, notice I'm not messing with the exponents anymore, because now I'm just adding, I'm just combining like terms. And once I get that set, I'm done. Now there's a couple of things I can do to kind of help myself out here. One of them is, if you look at your completed polynomial at the end, remember yesterday when we were saying, well, how do I figure out how many answers there are going to be? Well, I look at the degree. Well, how many answers are there? 3. 1, 2, 3. So I see in my completed polynomial at the end, this goes with this. There's 3 answers. I have a 3. If I had like 4 or 5 answers here, my final answer would have to be x to the 4th or x to the 5th. So those match. But otherwise, that's all you've got to do with these. So if we do the same thing in number 6, again, I'm using the opposite sign in each of my x's. Okay, and that's the critical thing here. I got to switch that sign, because otherwise I'd be getting zeros of the opposite numbers that I was looking for. And it doesn't matter which ones I do first. So I'm just going to go ahead. I'm going to do this one first. And once we do this one, I'm going to cover up the screen here for just a second. And I'm going to have you multiply out this last one and kind of see how it's going. Make sure things are going okay. Again, don't forget to combine those like terms. And once you get those there, remember, your next job is to deal with this times that x plus 7. So that will be where you are heading next. So I'm going to cover this up for a second. But people watching later, well, they'd have to like pause me or something. So what we're doing is we're going to go ahead and multiply our trinomial that we just got times that x plus 7, and hopefully that's going to give us a polynomial that is of the correct degree. So work that out, and momentarily here I will uncover things again and we can see if this went well or if there's a little thing we've got to tweak. One nice thing about this one is, since all the signs are the same, I don't have to worry about sign issues on this particular one. So I'm thankful for that. All right, if you're still finishing up, don't peek yet, but I'm going to uncover this so we can see how things are going here. So again, I've got a polynomial of degree 3, which goes along with the number of zeros I have. Because I have 3 answers, I have a degree of 3. But again, this is about detail. You know, are you remembering your exponents? Are you remembering that it's 7 times 6 and not 7 plus 6 when you're filling in the boxes? Things like that that can get you normally. So there's still that area of caution that we need to kind of pay attention to with these. Okay? Now, the last two, there's one big twist. You're like, zeros of 8 and I. Ooh. Note, imaginary solutions come in complex conjugate pairs. What the heck does that mean in English? Basically, it means is if I is one of your zeros, negative I will also be a 0, but they're not going to tell you that. So if you ever see an I as a 0, you always want the one of the opposite sign as well. So if they said the 0 was 8 and negative 4i, you'd also use positive 4i. So when I go to make my parentheses here, even though I originally only saw 2 values, there's really 3. But I'm still going to do my opposites. So the opposite of positive 8 is negative 8. The opposite of positive I is negative I. Right. And the opposite of negative I is positive I. Correct. But here's where I am going to stress order. Because on the first two, we said it really didn't matter what order I did them in. This time it kind of does. I always want to deal with my 2 quantities that have I first, because it's going to help me get I out of the way.
Because wouldn't they just cancel each other out then?
Right. And we're going to be able to simplify so there's actually no I's left. So let's get those I's out of the way here.
So it'd be x squared for first, and then a. I'm not sure how I would say that.
Yeah, it's weird, but negative ix, and we're not talking about the Roman numeral 9, plus ix.
And then they cancel each other out.
and they will, and minus I squared. Now some of you are saying, well, wait a minute, you were saying all the i's are going to go away. They will. Because once I multiply this out, positive and negative ix are opposites. They cancel.
Negative I squared is
and
just
what does I squared equal?
1.
Thought I heard it. Negative 1.
Oh,
So remember, if I squared is negative 1,
negative I squared.
this is really negative 1, but we don't talk that way, which is equals positive 1, okay? So that doesn't, this has become positive 1 because I substituted the negative 1 in for the I squared, okay? Just like what we did here. So this is really x squared plus 1. So you notice it's not even 3 terms when I multiply it out, which is nice. It just means my second box that I'm going to make only has to be a 2 by 2 again. This is one of my sides.
And then the other is one left over.
And the other one that's left over goes on the other side. And again, if you wrote the x squared plus 1, the x minus 8, that's fine.
So x to the third.
X to the third.
And then just x.
Okay.
And then negative 8x squared, and then negative 8.
Now, before some of you panic here and say, well, wait a minute, there's no like terms, Mr. Harty. These are supposed to be like. Maybe I multiplied wrong. No, you didn't. You're fine. The reason that happened was, you notice I missed a degree here and here. Not that I did something wrong, but it goes from x squared, and normally we're used to going x and then a value. Well, we don't have a regular x value. So when that happens, we just start with the biggest degree, and we just work our way down.
Did we have to factor those out?
Nope. That's my original polynomial for this problem that would give me those solutions. But the biggest thing on here, and we're going to see it again in number 8, is when you see a 0 that includes I, that they come in pairs. They're not going to tell you, like in number 8 about negative 2i. They're going to assume you know this. And now you do. Now there isn't an excuse. You do know this.
They were lazy. That's pretty much explains why.
No. They're just assuming your brilliance, that you remember these things. So again, opposites on all of my zeros. And again, I'm going to work with the I terms first. Now, some of you may get to a point you're like, well, wait a minute. If I know the middle 2 terms are going to cancel, can't I just skip to the chase and not worry about all this? Sure. But if you ever have issues at all with sign issues and stuff like that, I'd really suggest working it out until you're really sure that you're comfortable. Because then as we multiply, and don't let that second variable in there mess with you. Not a big deal. Because even though there's a 2 there now with my I, the process itself is going to work the same way. Because I still notice in that diagonal I have negative 2ix, positive 2ix. They're opposites and will cancel, and they always will. And then I remember, oh yeah, this I squared is like a negative 1. So negative 4 times negative 1 is positive 4, and that's what that literally becomes.
Wouldn't it multiply the I first and then square, or would it be 16?
No, because on here that this I squared is what you would look at first, because that's not going to my negative 4. I squared itself just equals negative 1. So this is really just negative 4 times negative 1.
Oh.
So that's why it's just the 4 and it's not a bigger value than that. So I just end up with x squared plus 4. And then just like we did back in number 7, so I get my x squared plus 4, and then my last binomial, x plus 5. And again, we multiply to fill the box. So if there's multiple terms with exponents, we just add them up. And just like the last time, we don't have any like terms, so we just start with the largest degree and work our way down. And that would be my polynomial term on this one. Now, before we get rolling along too far here, I want to take a peek. It's actually the first homework question because it throws a special case at you, and I don't want some of you flipping out on me here and going, oh my gosh, what is going on with... So I will get it drawn up here because that way it's also going to be online for reference if you happen to get there with it. We'll kind of blank out the background here a little bit. So when you get there, number 22 is the first one, and I'll write it up here. Because I gotta treat you. No, I don't have to treat you to anything. I need to get you to understand what can happen sometimes with a problem every once in a while. So before we even start this one, how many answers should I be getting?
4.
4. Okay. So we know there should be 4 answers. So we're like, okay, we hopefully are going to get to do this the easy way.
Oh, yeah.
So I'm going to go ahead and I'm going to get this typed in on my graphing calculator.
I did this one.
Now, especially when this is a longer one like this, you've really got to be careful to make sure that you type everything in correctly. Like if you miss an exponent or you put a minus instead of a plus or something like that, the entire answer is just wrong. So once I get this typed in, what we always do first is take a look at the graph and see how many zeros we visually can see. So we sit there, we say, okay, let's take a look here. Well, I see there's 1, and there's 1, and there's 1. So it looks at first glance like I see 3 values that would work, 3 zeros. So let's see if they're in the chart here. Okay, there's one of them. So I see that x equals 3. Oh, there's 1. I see one at -1. And there's the other one. Okay. Oops, -3 was the other one, wasn't it? And I didn't put the negative on it. Yep, okay. Okay, so I've got these 3. Now we talked about before, well, how do I do this? Because there's one answer, I don't see it. How does this work? So normally, and this is where I want you to kind of watch and see, because I'm going to do something that I think a lot of you would do, and then I'm going to show you the way to keep from doing this on your own. So let me put the graph back up here for a minute. Normally, we've been saying, okay, if I'm missing an answer, I'm going to take one of these values and I'm going to do synthetic division. So you're like, okay, I'll just use 3 since it's the first number here. So we get rolling. And I put in my 1 and my 4.
Oh, sweet.
And I do all of this, and I'm going along here. And I'm like, okay, pull my first value down.
Would it matter like which one you like divide by?
Doesn't matter. At the end, you'll end up with the same answer at the end.
Like no matter which one you use?
Yep, doesn't matter. I know it seems strange, but it's absolutely true. So pull it down, oops, that's positive 21. Add them down, 45. Add them down. And again, if I've done it right, I'll get a remainder of 0 because it's a clean factor. So I'm like, okay. And then I'm like, oh yeah, I started with x to the 4th, so I'm going to start one below that. So x to the 3rd and x squared and x and 9. I'm like, okay. But again, yesterday we talked about the fact that you've got to keep doing synthetic until it gets to a quadratic. And again, a quadratic means x squared. I'm not 2x squared yet. So I have to do synthetic one more time. And again, it doesn't matter which of the numbers I use. I'm just going to keep using them in the order I did here. So I'm going to go to -1 next. So I'm going to do it one more time using this. Okay, so I'm going to use 1, 7, 15, and 9. Let's see what happens here. So I'm going to pull my 1 down, multiply, and add, multiply, and add, Sweet, multiply, and add. And I'm like, okay. So now I start one below this one. So I'll start with x squared, and x, and 9. And this should be the one that ends up being factorable. So I'm like, okay. So x squared plus 6x plus 9. What multiplies to 9 but adds to 6? 3 does. And you're like, well, wait a minute, though. If I set that equal to 0, well, that's not doing me any good because I subtract the 3. I already have that answer. Well, how the heck am I supposed to get my fourth answer? Because I just got the same answer over and over. Here's the secret. This won't happen often, but it does happen occasionally. There's this certain little thing that's called a double root. And in math, we call it a bouncer. Here's what I mean by that. If you notice, this point right here, it hits the x-axis, but it doesn't go all the way through. Like this one, it goes through and it just keeps going. This one goes through and it just keeps going. This one bounces off the x-axis and goes back up. And when I use the word double root, it means it's a double solution. That's the answer twice. So here, you'll notice, what answer did I get at the end? -3, which I already had. -3 twice is my fourth answer. Now, do I have to go through all this work if I remember that that bounce point counts as 2? No. But if you forget and you get all the way to the end and you get a repeat of one of the answers you already had, that's why. And that does need to be written again because that's how a double root works. They don't happen often, but you notice it happens on the very first homework question of all places. So I'm not going to guarantee that it won't happen again in the homework.
Wait a minute.
Uh-huh.
That was on the... Oh, I could just finish the answer.
So it's true. You're done. So when you're doing your homework, again, use the graph to come up with any zeros you can. And if you get them all, that's great. But if not, use the synthetic division like we just did here to finish it up, and you'll find any missing answers. Some of the answers are on the sideboard, so you can kind of check as you go along and see if you're doing okay. The key has miraculously disappeared second hour, so I don't know where the key is, to be perfectly honest. So if you have an issue, maybe I'll just leave my book open up here, and you can check an answer as you go until I can recover the key. And yes, I am